Alright, so here we are starting in section 7.3, and this is our introductory lesson to logarithms. Okay, so logarithms is just a special way to ask a specific question. And so let's fill in what the question is first. Okay, so the question is, what exponent is required to go from a base of b to reach a value of a. Alright, so what exponent is required to go from a base of b to reach a value of a? So in this box right here, we're going to write out what a logarithm looks like. So log base b of a is going to equal to x. Okay, so if you look specifically at my question right here, base of b, okay, we're talking about base of b, and to reach a value of a, okay, which means that x out there must be my exponent. Alright, now to draw more attention to this and to show the relationship between exponential form and logarithmic form, let's write it in both forms. Okay, so you've already seen logarithmic form. That would be log base b of a equals x. Okay, and we already talked about b here is my base, a here is my answer, and x is my exponent. Alright, now this makes a lot more sense when we write it in exponential form, because you'll see exactly what I'm talking about here, okay? Exponential form, base b taken to the x power equals a. Alright, so these are one and the same. They are equivalent to each other. Exponential form and logarithmic form, they just look a little bit different, okay? So again, we're going to label this as well. The b still stands for the same thing, base. A stands for the answer, and x is my exponent. Alright, so again, those are equivalent to each other, just one is in exponential form where the other is in logarithmic form. Alright, so again, this is a introductory lesson, so let's do some examples here, okay? Now, before we get over here to the left side, because these are kind of backwards here, you notice the left side says calculate the following logarithms, okay? And then the right side says to convert between exponential and logarithmic form. Alright, so let me zoom in here a little bit. We're actually going to work on the right side first, because I just mentioned a minute ago that this is kind of backwards. And so I want to actually do some converting first, okay? So you have a little bit of converting to do here in 7.3. So when you get into Hawks here, you're going to see a few of these that are going to tell you to convert between one form to the other. Alright, so on the left side, you see that these are all written in exponential form. On the right side, these are written as in logarithmic form, okay? And so we want to convert it to the other form that is not pictured. Alright, so we have log base of 1/5 of y equals x. Now, don't forget, these always equal whatever the exponent is, okay? Now, I'm going to go ahead and continue going down here, so we can knock out these three here that are already in exponential form. Alright, so we have log, what's my base? Base 9. What's my answer? X equals y. Alright, next one here, log base 6 of my answer, which is x, equals my exponent there of y. Okay, so log base 6 of x equals y. Alright, we've got three more here. This next one, log, what's my base? Base b of my answer, which is 123, equals my exponent, which is a. Alright, next one down. Log base u of my answer, which is v, equals negative 14. And I'm just putting negative 14 there in parentheses so that way it doesn't get lost in the equal sign there. All right, one more. Log was my base, 8 of my answer, which is a, equals b. All right, so don't forget that your base will always be kind of offset there. It'll be dropped. It won't be on the same level as log. It'll be dropped a little bit, kind of the opposite of an exponent. It'll be dropped downward instead of upward. All right, so log base 8 of a equals b. All right, scroll back up here. Notice the right side. I've already mentioned this. The right side is they're already in logarithmic form, so I need to convert these to exponential form. Okay, so first off, we're going to start with our base. My base happens to be u. All right, so we have u to the what power? That would be v, equals my answer, which is 15 over 16. There we go. All right, next one down. My base is 7/4 taken to the y power equals x. All right, next one down. Base of u to the negative 16 power equals v. All right, next one down. Base of v this time, v to the 4th power equals u. Last two. Base of 2 to the u power equals v. And the last one, base y to the negative 8 power equals x. All right, now of course if I'm doing these too quickly, feel free to pause the video to see if you can write it down first before I just go right into the answer. All right. Now that is 1/2 of our little foldable here, converting between exponential and logarithmic form. Excuse me. Now the other side of this is calculating the following logarithms. Okay. All right, so I'm going to zoom in here so we can see the first two here. All right, now our first thing we need to do is we need to go ahead and convert this to exponential form. Now notice this is an expression and not an equation. Remember, an equation has the equal sign. Okay. Now we cannot solve an expression. We must convert this to an equation, okay, which means we have to put equals x. Okay, we need a variable on there because we're going to be solving this. Okay, all right. So now that we put that equals x on there, now we convert this. Now we can convert this back to an exponential equation. Okay, so 4 to the x power equals 64. Now this goes right back to lesson 7.1. I need to find a common base here for 4 and 64. Let's see, 4 to the 3rd power is 64. So 4 to the x power equals 4 to the 3rd. Now do y'all remember what I can do with those bases? Now that they're the same, I can cross them out and we equate the powers, and that means x equals 3. Not a whole lot of solving to do right there. X equals 3. Okay? And if I plug it back into here, it really makes a lot of sense because 4 to the 3rd power is 64. All right, let's go down here to this next one. Okay. Now, again, that's an expression, so I need to set this equal to x. All right, base of 4. 4 to the x power equals 16. Again, I need to have a common base. So 4 to the what power is 16? That would be 4 squared. So 4 to the x power equals 4 squared. I can cross out my bases now that they are equal. And x happens to equal what number? That would be 2. Alright, and again, if I plug it right back into here, we can see that 4 squared does equal 16 itself. Okay, now before I scroll down, let's go ahead and work the 2 here on the right hand side as well, okay? Again, so we're looking at an expression here. We need to change it into an equation and then convert it. 6 to the x power equals 216. Alright, I need to find common bases for 6 and 216. That would be 6. So 6 to the x power equals 6 cubed. 6 times 6 times 6, I believe, is 216. We can cross out the 6's because they are equal, and we get x equals 3. Alright, which is my answer. Alright, now, look carefully at this next one here because we happen to have a fraction here, okay? So again, our first step here is to convert this to a exponential. So 3 to the x power equals 1 over 243. Alright, now, most of us don't like fractions, okay? Remember I brought that up in class many times. So let's get rid of that, okay? So to be able to flip this, we're going to use a negative exponent. So 3 to the x power equals 243 to the negative 1 power, okay? By using that negative exponent, it allows me to flip those fractions, okay? Alright, so now I need to find a common base here for 3 and 243. 3 to the, in case you're wondering what I'm doing, I am punching this on a calculator just to double check here. 3 to the 4th power is 81. 3 to the 5th power is 243. Okay, good. Okay, so 3 to the x power equals 3 to the 5th power. Let's not forget that we also had that negative 1 there. Okay? Alright, so we went from here to here. Alright, now, let's not forget what we have to do with these right here. Okay? When we have a power to a power, we have to multiply these, okay? Alright, so let me write that. Multiply. There. Okay? 5 times negative 1. So let's write that. 3 to the x power equals 3 to the negative 5. Okay, now you might be tempted to cross out those 3's before multiplying that 5 and that negative 1, but I encourage you, make sure you follow through. Make sure you have one exponent. There, one exponent. Alright, so now we can cross out the 3's and we get x equals negative 5. Alright, and so if I go to my calculator here and I go 3 to the negative 5 power, that gives me a really long decimal, which is interesting. But if I do 1 divided by 243, those match. Those really long decimals match. Okay? So again, I was just doing a quick check. I was doing it on my calculator. Again, I don't have the capability of doing it on my screen. But if you are confused about that or anything, please just shoot me a question, and I'll try to figure a way to write those directions down as far as punching it into your calculator. Alright, let me move down here a little bit so we can see the next two. Alright, looking over here on my left-hand side, we have log 5 of 125. Again, we have to set that equal to x. Change that to exponential, so 5 to the x power equals 125. I need a common base here for 5 and 125. I believe that's 5, so 5 to the x power equals 5 cubed. At this point we can't cross out the 5's because they are equal to each other, and we get x equals 3. And again, if I plug it into here, 5 cubed is 125. Alright, next one. Set this equal to x. Change to an exponential. 343 to the x power equals 7. Now that's 7. That's a pretty large number. Let's do 7 to the 3rd power. Oh, 7 to the 3rd power is 343. Nice. Okay, so 7 to the 3rd power was 343. got to bring down that x, equals, now this does have an exponent, we can't forget we have to put a 1 next to that, okay? 7 to the first power is still 1. Don't be tempted to use 0. Please do not use 0, because anything to the 0 power is always equal to 1, and we still want this to equal 7. Alright, just like we did in an earlier example, we need to do something with that 3 and that x. Alright, so 7 to the 3x power equals 7 to the first. We went from here to here. Now I can cross out those 7s. We get 3x equals 1. Now we have to do a little bit of algebra here, which means I'm going to have to divide both sides by 3. And we get x equals 1/3. X equals 1/3. Alright, so this one's a little bit harder to punch into your calculator, but you can do 343 to the 1/3 power. And it comes out exactly to 7, so it checks. Alright, moving over here to the right-hand side. Okay? We have to set that equal to x to change it to an equation. 2 to the x power equals 4. Alright, common base for 2 and 4, I believe, is 2. So 2 to the x power equals 2 squared. Cross out the 2's. X equals 2. That one was an easy one, wasn't it? Okay. Because again, if I punch that in there, 2 squared does equal 4. So that was an easy one. Alright, next one here. Set this equal to x. 2 to the x power equals 16. Need a common base for 2 and 16. Looks like it's 2 again. So 2 to the x power equals 2 to the 4th power. 2 times 2 times 2 times 2, yes. Cross out the 2's. X equals 4. Alright, and again, if you punch that into your calculator, 2 to the 4th power does in fact equal 16. Alright, two more down here. Alright, we have this one down here, which I almost missed. Alright, so again, we change its exponential. We have 64 to the x power equals 4. Alright, I need a common base here for 64 and 4. That would be 4. 4 to the 3rd power. I'm going to double check that real quick. 4 to the 3rd power is in fact 64. Okay, don't forget to bring down that x. Equals 4. And what do I need to put there as an exponent? Could it be 0? Could it be 1? It would be 1. Alright, so we need to do something with that 3 and that x first. Okay, so 4, that's 3 times x, so that'd be 3x equals 4 to the first. Let's cross out those 4's because they are equal now. 3x equals 1. Divide both sides by 3. And we get an answer of x equals 1/3. Alright, so I'm just going to say this out loud again. I'm going to go ahead and do 64 on my calculator divided by, or I'm sorry, not divided by, 64 to the power of 1 divided by 3 comes out exactly to 4. And that's exactly what I want. Alright, one more. Log 6 of 1 over 216 equals x. Alright, so we have 6 to the x equals 1 over 216. Let's go ahead and flip that by using a negative exponent. Okay. Alright, so again, we're going to flip this by using a negative exponent. So that's going to give me 216 to the negative 1 power. Alright, I think we had 216 earlier, didn't we? 6 to the 3rd power, I believe. Yeah, 6 to the 3rd power is 216. So, 6 to the x power equals 6 cubed, and then don't forget to bring down that negative 1. Okay, we have to do something with that 3 and that negative 1. that would be multiply them. So 6 to the x power equals 6, and that's 3 times negative 1, so that would be negative 3. Let's cross out those common bases, and we get x equals negative 3. Now again, I'm putting it in parentheses just to kind of separate it from that equal sign. Okay? And again, if I go back and I do 6 to the power of negative 3, I get a really long decimal like I did earlier, okay, 0.004629626. But if I also do 1 divided by 216, which was my answer up there, I also get 0.004629626. Alright, if you get stuck on lesson 7.3, don't be afraid to send me a screenshot. Hope everybody's doing